the distance formula. It should be familiar to us because we've already learned the slope formula, and the process is very, very similar. You'll notice we've got an x2 minus x1 and a y2 minus y1. But this time, that's right, instead of dividing the two, like in the slope formula, we're squaring them, adding them, and then because my distance here is squared, we're going to take the square root. So we'll get to those steps in a second. The distance formula we can use to find the distance between 2 points, or the length of a side for a shape on a coordinate plane. That's what we're going to build up to. We're going to start talking about triangles here at the end of the week. Today we're just looking at the distance between 2 points. So do me a favor, go ahead and highlight this formula, just so when we're flipping through our notebook, our eyes get drawn to it in case we need it, which we will. And we're going to do exactly what we did with the slope formula. We're going to label our coordinates, x1, y1, x2, y2, substitute all those numbers in, and then use our PEMDAS rules to solve. So, example 1, find the distance between the points 3, 4, and 6, 10. Well, let's do these two. Oops. Everything's fine. So, I got 3, 4, and I got 6, 8. If you remember from the slope formula, which I know was a long time ago, hopefully we remember, we're just going to label left to right, x1, y1, x2, y2. x1, y1, x2, y2. x1, y1, x2, y2. This is the x coordinate of my first point with the y coordinate of my first point. The x coordinate of my second point with the y coordinate of my second point. So we'll label 3, 4 as x1, y1, 6, 8. That's not the right number. What happened there? Which one is it supposed to be? Forgot a minus 4 is 4, 3, 16 plus 9. Oops, this one is supposed to be 36 plus. Yeah, this one is supposed to be an 8 up here. Go ahead and change that real quick. This 10, y2 is supposed to be an 8. Don't know how I messed that up, but things happen. So change that 10 to an 8 for me real quick. So we've got x1, y1, x2, y2. All right? We start with our distance formula. D squared, not just D, D squared equals x2 minus x1 squared plus y2 minus y1 squared. The hardest part is just plugging all these numbers in correctly. My first one is x2. What number am I going to plug in for x2? 6. What am I going to plug in for x1? 3. Okay, that's just how we labeled them. x2 is 6. x1 is 3. What am I going to plug in for y2? What am I going to plug in for y2? 8. Thank you. What about y1? y1? 4. We're just looking. We're not making these numbers up. We're just looking at what we labeled, right? If we plug them in the wrong order, because we're subtracting, we're going to get the wrong answer. So I want to make sure we get that, okay? So we started with the distance formula. We plugged in each coordinate. That's step 1. Where's my gray? Let me just do this. Plug in each coordinate. That's step 1. Now we're going to solve inside the parentheses, right? PEMDAS. The first letter of PEMDAS is P, which stands for parentheses. Inside my first parentheses, I have 6 minus 3. What would that give me? 3. And I've got 8 minus 4 in the second parentheses. What would that give me? 8 minus 4 gives me 4. What does the E in PEMDAS stand for? Exponents. So we're going to take these exponents and we're going to apply the exponents. Okay? What would 3 squared give me? 3 times 3, which is 9. What about 4 squared? Think again. 16. 4 times 4, not 4 times 2. It's 4 squared, giving me 16, right? All right. Step 4. I'm going to add the two numbers together. What would 9 plus 16 give me? 25. Okay, stay with me, guys. So we get d squared equals 25. That looks just like the problems we were just solving on Friday and on that worksheet 56 that we reviewed. The last thing we need to do here is square root both sides. Square root the left, square root the right. We know that the square root of d squared just gives me d. What would the square root of 25 give me? 5. D squared, when we take the square root, simplifies to just d. 25, when we take the square root, simplifies to 5. Therefore, the distance between these two original points is 5 units. That's right. Darius, go ahead and read this out loud for everyone. What does it say on the very bottom? That's right. We don't need a plus or minus sign here because distance cannot be negative. If I told you to go -5 miles, that wouldn't make any sense. Well, walking backwards is still a positive distance, right? You can't go a negative amount of distance. Any distance in any direction is positive. So when we're finding the distance, we don't want to use plus or minus. We just write the number. Please stop laughing. Okay. Any questions on how we made it through that? Those 5 simple steps. Let's see. I want to do another example before we get started on the worksheet. Let me think of something over. So I've got -2 and -1, 4 and 3, 4 squared plus 6 squared. Okay, let's do that. Go ahead and flip over because I doubt we have room after gluing that in. Let's do another example. Let's say we want to find the distance. It feels weird writing notes out by hand. -2, -1, and 4, 3. Find the distance between the points, -2, -1, and +4, +3. The very first thing that we want to do here with these points. Label them. That's right. Thank you. We got to label them. We got to know what goes where. What are we going to call -2? X1. Perfect. What about -1? Y1. How about my positive 4? x2 and y2. Left to right, we always want to label them that way just to be consistent. x1, y1, x2, y2. I'm going to write out my distance formula. D squared equals x2 minus x1 squared plus y2 minus y1 squared Now we've got to plug them in. So I'm going to set up my equation again without all those variables. Something minus something squared plus something minus something squared. I got to know what all my somethings are. What number am I going to plug in for x2? Take a look at what we labeled x2 as. 4 is my x2. x2 becomes 4. What am I going to plug in for x1? Negative 2. Don't forget that negative sign. Negative 2. I'm going to zoom in. There it is. That's right. There's a minus sign in the middle. And we just plugged in a negative 2. So two minus signs right next to each other make a what? A plus. We'll get to that in a second. What am I going to plug in for y2? 3. What am I going to plug in for y1? Negative 1. Another double minus. I'm going to write this in a separate step just so we don't forget. I now have 4 plus 2 and 3 plus 1. Because two minus signs make a big plus sign. All right? It says two minus signs make a big plus sign, which we should know by now, hopefully. I'm going to follow PEMDAS now and solve inside the parentheses. What would 4 plus 2 give me? 6. What would 3 plus 1 give me? 4. I still have to square them, and this is all still equal to d squared. Now, what is 6 squared equal to? 36. What is 4 squared equal to? 16. All equal to d squared still. And what is 36 plus 16? 52. 30 plus 10 is 40. 6 plus 6 is 12. 40 plus 12 is 52. That's the way I think about it in my head. So now I'm left with d squared equals 52. Is that my answer? 52 units between those 2 points? No, because I have one last step to do. What was my last step over here? Step 5. Square root both sides. We want to get d all by itself. Right now, it's not all by itself. It's being squared. This is why we did those square root equations last week, because now we've got d squared equals 52. I'm going to square root the left and square root the right. What's the square root of d squared? What would this simplify to on the left? Just d. And over here, if I have 52, I'm going to do a little factor tree off to the side. What two numbers multiply to give me 52? 2 and 26. Good. What two numbers multiply to give me 26? 2 and 13. It's kind of like the number 18 we went over just now on worksheet 56. I've got a 2, a 2, and a 13. So d is equal to the square root of 2 times 2 times 13. Make sure you understand how we got there. So any questions I can answer before we finish this off? Give me a thumbs up if you're following this process, this example so far. Good. Okay. Is there any pairs we can circle up and bring out here? Yep, I got a pair of 2s. That's going to go out in the front. What gets left over inside the square root? 13 gets left over. So d is equal to what? 2 root 13. Do we need a plus or minus sign here? No, why not? Because distance cannot be negative. We just highlighted it on the front. We do not need a plus or minus sign right now because distance cannot be negative. D is equal to just 2 root 13. Not plus or minus 2, just 2 root 13. I know that looks like a lot of steps, but hopefully it's fairly straightforward to follow. Couple things, be very careful when you've got double negatives or even a negative in the front. If you miscalculate this and add or subtract incorrectly, the whole rest of it, you're done. It's not going to work out how you want it to, okay? There's the end of that. All right.